Hello everyone. Welcome to the topic of predicate logic. So far, we have considered a simple form of logic. But, there are a few statements that are not true, or false. For example, let P be the statement, x is an integer greater than 2. Then P is true if x equals 3 but P is false if x equals 1. A propositional function P, x, is a statement involving a variable x. For example, P, x, is the statement, 2x is an even integer T5 enter. In this example, x is an element of a set D where D is the domain of P, x. D must be defined and in this case for instance, D is the set of integers. Most statements in mathematics and computer science use terms such as for every and for some. For example, for every triangle T, the sum of the angles of T is 180 degrees. In a star network system, every nodes, computer, workstation, peripheral, are connected to a central hub. One can write P, x, for every x in a domain D in symbols. This symbol Porsche is named as the universal quantifier. The symbol may be read as for every, for all or for any. The statement for every x P, x, can be true or false depending on the value of x. The statement P, x, is true if P, x, is true for every x in set D. The statement P, x, is false if P, x, is not true for some x in set D. Let's use an example to illustrate the truth of a propositional function. For example, let P, n, be the propositional function. N squared plus 2n is an odd integer for every n and D where D is the set of all integers. You can verify for yourselves that P, n, is true for cases where n is an odd integer, but P, n, is false when n is an even integer. One can write there exists an x such that P, x, where x is in a domain D in symbols. This symbol is known as the existential quantifier. The symbol may be read as for some, for at least one or there exists. The statement, there exists an x such that P, x, is true or false will depend on the value of x. The statement is true if P, x, is true for at least one element x in D. The statement is false if P, x, is not true for every x in D. We know that for every x P, x, is false if there exists an x in D such that P, x, is false, and the value x that makes P, x, false is called a counterexample to the statement xp, x. The order of quantifiers is important. Changing the order can change the meaning. Let L, x, y, be the statement x knows y. If we have, then the statement becomes for every x, there exists a person y such that x knows y. In other words, everybody knows somebody. Let's continue with the previous example to explore different order of quantifiers. This statement says there exists a person x such that for all y, x knows y. In other words, it means somebody knows everybody. This statement says for every person x such that for all y, x knows y. It also means everybody knows everybody. This statement says that there exists a person x, there exists a person y such that x knows y, somebody knows somebody. The statement using multiple quantifiers can be true or false depending on the value of x and y. The statement is true if for every x in D, there is at least one y in D for which P, x, y, is true. False if there is at least one x in D such that P, x, y, is false for every y in D. Let's look at another example. The statement is true if there is at least one x in D, such that P, x, y, is true for every y in D T4 enter. False if for every x D, there is at least one y D such that P, x, y, is false. Let's look at another combination of multiple quantifiers. The statement is true if for every x in D and for every y in D, P, x, y, is true. The statement is false if there is at least one x in D and at least one y in D such that P, x, y, is false. Let's look at last combination of multiple quantifiers. The statement is true if there is at least one x in D and at least one y in D such that P, x, y, is true. The statement is false if for every x in D and for every y in D, P, x, y, is false. There is a generalized De Morgan's laws for logic which says that, if P, x, is a propositional function, then each pair of propositions below have the same truth values. For example, the statement for it is not true that for every x, P, x, holds, is equivalent to. There exists an x for which P, x, is not true. Similarly, generalized De Morgan's laws for logic also says that, if P, x, is a propositional function, then each pair of propositions below have the same truth values. For example, it is not true that there exists an x for which P, x, is true, is equivalent to, for all x, P, x, is not true.